Today's lesson, we're going to do a little warm-up from yesterday and the day before. When you multiply with the same base, you're going to add the exponents. So we're going to have 3 plus a negative 5, so it'd be 5 to the negative 2. When I want to change that to a positive exponent, I'm going to have 1 over 5 squared, and then 5 squared is 25, so 1/25. Second one, when I have a negative exponent, I want to rewrite it positive, so I write it as a fraction. Negative 3 squared, don't drop your parentheses here. Negative 3 times negative 3, we're going to have 1 over 9, 1/9. And then when I divide, I want to subtract my exponents. 6 take away 4, 4 squared, which is 16. So now that we're warmed up from yesterday, we're going to talk about the difference between positive and negative exponents with the number 10. The difference between 10 to the 4th and 10 to the negative 4th. 10 to the 4th is 4 10s multiplied together, which would be 1 or 10,000 here. 1 with 4 zeros or 10,000. And then 10 to the negative 4th is, I write it as a fraction first, and it would be 1 over 10,000. So the difference is with the negative exponent, it's a very small number. With a positive exponent, it's a very large number. Now, scientific notation, you have a coefficient, a base, and an exponent. The coefficient has to be a number between 1 and 10. It can't be over 10, and it can't be less than 1. The base is always 10, and your exponent is whatever you need it to be for the problem. So that 6.022 times 10 to the 23rd would be a very, very large number. Use scientific notation for numbers that are very, very big or very, very small. You see these a lot, hence scientific in science for numbers that are huge, like the distance to the sun, and then really small, like how big a cell is or measuring a cell. Okay, so to convert from the scientific to standard notation, I'm not going to bore you with reading those because you can read over them. When you're in scientific notation, you want to, and you have a positive exponent, you're going to move to the right as many places as the exponent is. So when we have 5.46 times 10 to the 7th, I need to move my decimal place 7 times. 1, 2, 3, 4, 5, 6, 7. And then I rewrite it so that it looks nice. It's a very large number, so I'm going to put in all of my commas, so 54,600,000. Now, if it's negative, you're going to go the opposite direction. You're going to go to the left. It actually creates a very small number, not a negative number, but a very small number. So negative 6 would be loops 1, 2, 3, 4, 5, 6 in that direction. And then I rewrite it to make it look really nice. 1, 2, 3, 4, 5, 1, 2, 3. Make it look nice with your decimal place in there, then circle it. So when it's positive, you're going to move to the right. Negative, you move to the left. Now, a negative number just means it's going to be a negative number at the end. It doesn't change anything. So I have negative 4,700. And then a negative exponent, it moves to the left. 1, 2, 3, 4. I call them loops. Somebody may have called them butt cheeks in your past, but they're loops. Negative 0.00068. Then I have to the 5th power, so it's positive. I'm going to move it to the right. 1, 2, 3, 4, 5. Fill out the empty loops with zeros. Rewrite it so that it looks nice and put your commas in. And because it started off as a negative number, it ends up as a negative number. Once again, we have positive, so it's going to move to the right. 1, 2, 3, 4. Fill in your loops. Rewrite it so it looks nice, and if you need commas, they're in there as well. Now we'll move on to switching the other direction, going from standard back to scientific notation. We're going to try our word problem here. Nick won the lottery and brought the ticket to school. Carter asked him how much he won, and he said 4 to the 6 times 10 to the $7. Now, it wouldn't make much sense to use Scientific notation, when you're saying how much money you have, because you want to brag about it, how much did he win written in standard notation? So 4.6 times 10 to the 7th would be 7 loops. 1, 2, 3, 4, 5, 6, 7. Fill in those zeros. Let's see how much he won in the lottery. Rewrite it so that it looks nice and we can read it. Put in your commas. And a cool 46 million's not a bad day. Now we're going to convert from standard to scientific. All right, we're going to convert from standard to scientific notation. The number out front is super important. It has to be between 1 and 10. It must be between 1 and 10. So like if I'm looking at the first one, my number's not going to be 30. It's not going to be 0.3, but it should be. So I want my whole number to be 3. My first number, I shouldn't say whole number, but it happens to be a whole number in this case, to be 3, and then times 10 is always my base, and then my exponent is how many spaces I moved. If it's a very small number, it's a negative exponent. If it's a very large number, it's a positive. So let's count. 1, 2, 3, 4, 5, 6, 7, 8. So it's going to be 3 times 10 to the negative 8. The first number has to be between 1 and 10. The base is 10. And then the exponent is how many spaces you move to make it the number between 1 and 10. And then it's negative if it's a small number, positive if it's a big number. This will be 8. 8 times 10, I'm going to move it twice. And it's going to be negative because it's a small number. So 8 times 10 to the negative 2. Now, the next one with the 576,000, the number has to be between 1 and 10. So I want my decimal to go between the 5 and the 7. That's going to make my out front number 5.76 or 5.76. That's in between 1 and 10 times 10, and I'm going to count 1, 2, 3, 4, 5, 6, 7, 8 times 10 to the 8th because it's a super large number, so 8 positive exponent. Next one, the number is going to be between 1 and 10, so I'm not going to have 78, I'm not going to have 780, I'm going to have 7.801, and I'm going to use all the digits that are not 0, 1, 2, 3, 4, 5, 6, times 10 to the positive 6 because it's a really big number. On the next one, I'm going to have my decimal in between the 4 and the 6, 1, 2, 3, 4, 5. So I'm going to have 4.6 times 10 to the positive 5th, and it was just happened to be a negative number, so it's negative out front. Then the last one here, between 6 and 2, 6.2 times 10, and then 1, 2, 3, 4 to the negative 4th. And it's not negative, so we'll leave it like that. And then the last 4 I'd like you to try on your own. So at this point, pause the video, try them on your own, and then I'm going to have the answer on here. So pause the video, try these 4, and then play it back, and I'll have the answers on here for you. So at this point, pause, and then come back to me. And as you're doing that, I'm going to go through it. 3.21, 1, 2, 3, 4, 5. At this point, you should be checking your work with mine. These should be practiced on your own. 8.99 times 10 to the 1, 2, 3, 4, 5, positive 5th. Like I said, at this point, you're just checking with me. You should have tried these on your own. Rewrite them nice with commas if you need to. 1, 2, 3. 0.004401. Check yours with mine. Hopefully you got 100%, and you, my friends, can start your homework. Have a great day.